In this video, we will learn about the cause and expression for upthrust. So we have seen above that whenever an object is immersed in liquid, an upthrust acts on the object in vertically upward direction, like this. Now let us understand the cause for this force of upthrust and then find a mathematical expression for the magnitude of this upthrust force. Now, cause for upthrust force. We know that a liquid contained in a vessel exerts pressure at all points and in all directions. For points on one horizontal plane inside a free liquid surface, the liquid pressure is same in all directions. Okay? Like if here is P1, here P1 also, every point will experience P1. Here at P2 position, all these points will experience P2 pressure. Now, however, the liquid pressure increases with the increase in depth. Due to this reason, P2 will be greater than P1. Now, let us take a object or a block inside a liquid as shown in this particular figure and let the liquid pressure in downward direction on the upper face be P1 and the pressure in upward direction on the lower face be P2. Now, the net pressure difference between these would be P2 minus P1, that is acting in upward direction. Now, I can say that the force acting or the net force acting would be equal to P2 minus P1 into the area. Now, these act in upward direction, and this upward force is what we say the upthrust force. Now, of course, pressure and force is also acting on the side walls of the block. However, forces on the opposite side of the wall being equal in magnitude and opposite in direction like this nullifies each other. Thus, the net upthrust force acting on the block due to the liquid is given as P2 minus P1 into area. Mathematical expression for upthrust. Now it is found that whenever an object is partially or wholly immersed in a fluid, a liquid or a gas, an upthrust acts on it, whose magnitude is equal to the weight of the fluid displaced by the immersed part of the object. Now to prove the above statement, or to find an expression for upthrust, let us consider a uniform cylindrical object of cross-section area capital A, height h, immersed in a liquid of density rho, as shown in this particular figure. Now the upper surface, that is KL, of the cylinder be at h1 depth and lower surface NM be at h2 depth below the free surface of the liquid. Now liquid pressure on the upper surface be P1 and on the lower surface be P2. Now the force on the upper surface will be equal to pressure on the upper surface into area. Now the pressure on the upper surface is H1 into rho into G, and that would be in downward direction. Similarly, on the lower face, the force will be in upward direction and is equal to P2 into area. That is equal to H2 rho G into area, right? Now, the horizontal thrust on the vertical sides of the cylindrical object due to the liquid get balanced because liquid pressure is same at all points at same depth. Now, the net upthrust force, that is FB, will be equal to F2 minus F1. That would be equal to H2 minus H1 into rho G area. We know that H2 minus H1 is equal to height of the cylinder h. So I can say the upthrust force is equal to h rho g area. Okay. Now I know that height into area is equal to volume of the cylindrical object immersed in liquid. Now it is equal to the volume of the liquid displaced by the immersed object. So I can say the upthrust force will be equal to volume into density into g, that is gravitational acceleration. From this relation, it is clear that the upthrust force or the upward thrust is equal to the volume of the liquid displaced into density of the liquid into acceleration due to gravity. Or I can say that volume of the liquid displaced into density of the liquid as equal to mass of liquid displaced. So I can write it as upward thrust is equal to mass of liquid displaced into acceleration due to gravity. Now I know that mass into acceleration due to gravity mg is equal to weight of the liquid displaced by the immersed part of the object. I hope this topic is clear to you. Thank you.